A pleasant morning to each and everyone. This is Joyce Anbare, your discussant for today, and this is a continuation of the report of Ms. Gillian Botero Sicat according to experimental evidences of brain organization, and my topic is about event-related brain potential or ERP. So, normal aging brings increased richness in knowledge and experience as well as declines in cognitive abilities. Event-related brain potential or ERP studies of language comprehension corroborate findings showing that the structure and organization of semantic knowledge remains relatively stable with age. Our cultural adages tells us that with age and experience comes wisdom, and indeed, empirical data show that healthy older adults often have richer vocabularies and augmented stores of world knowledge according to Light 1992. However, aging also brings decline in both physical and psychological abilities, like for example, a sore back or more difficult climb up the stairs may be accompanied by decreased ability to remember a phone number or the grocery list, increased tip of the tongue experiences, and harder time focusing concentration on a particular task. These psychological facets of normal aging are likely to become more consequential as life expectancy continues to increase in developed world as medicine offers more solutions to physical problems of aging. Older adults rely on different neural pathways and cognitive processes during normal, everyday comprehension, including a shift away from the predictive use of sentential context, differential recruitment of neural resources, and reduced engagement of controlled processing. Within age groups, however, there are important individual differences that, for example, differentiate a subset of older adults whose processing patterns more closely resemble that of young adults, providing a window into cognitive skills and abilities that may mediate or moderate age-related declines. So these are some examples of age-related declines. We have the electrophysiology of language and the aging brain, word level semantic processing, building a message level representation. So first one, electrophysiology of language and the aging brain. Language is fast, complex, and hierarchically constituted. Successful, successful translation of the noisy, relatively arbitrary, and often ambiguous language stream into meaning requires equally rapid cognitive processing composed of sub-processes using multiple mechanisms or several interacting levels. For now, I am going to provide a video explanation about electrophysiology of language and the aging brain.
To neuron, reducing the rate of communication in the nervous system and affecting our cognition as we grow old. Cognitive decline isn't uniform in the brain. The hippocampus, crucial for memory formation, and the prefrontal cortex, important for any high cognitive thinking, are affected the most. This region have large energetic demand that the declining mitochondrial function with age cannot satisfy. This explains the very common cases of dementia in old adults.
The most common type of dementia is Alzheimer's disease, with nearly 50% of adults over the age of 85 are fighting against it. In addition to the loss of neural connection in the normal aging, the Alzheimer's brain also has an accumulation of misfolded proteins which are harmful to neurons. Other concerned phenomena of aging across species are the deterioration of the immune system, and the inability of stem cells to replenish cells. As a result, the Alzheimer's brain cannot repair damaged neurons. However, aging is a surprisingly plastic process in the sense that it can be manipulated by genes, evolution, and diet. Indeed, diversity in lifespan across the tree of life is constantly challenging the notion that age is immutable.
We are not obligated to stay vulnerable with this natural advancement of life, as our lifestyle can directly influence how we age. To start our day right, we need 8 hours of sleep. When we sleep, a cleaning mechanism in the central nervous system is active to get rid of waste product in the brain and spinal cord. Physical activity are effective in improving cognitive performance for people of all age. A routine of exercise 3 times per week will go a long way. And last but not least, let art flourish your life as you age, because creativity challenges the mind and enhances the brain communication network.
The neural activity is recorded in real time so that the ERP provides a millisecond level record of brain activity that is congruent with cognitive processing rather than occurring several hundreds of milliseconds downstream. As juries of behavioral measures as well as imagining methods, such as functional magnetic resonance imaging that measures slower hemodynamic signals. These characteristics also affords the functional specificity of ERP components, identifiable features of the waveform that are associated with particular cognitive and neural processes. So now let's tackle the next age-related declines, and this is the word-level semantic processing. Lexical semantic knowledge and the organization of this information have been shown to be quite stable throughout adulthood. Older adults tend to generate similar word associates and category exemplars, as do younger adults that are matched for verbal abilities, according to Burke and Peters of 1986 and Howard of 1980. A possible exemption, however, comes from work examining the processing of words with multiple meanings. This result thus suggested an age-related shift of subordinate meaning activation from the left hemisphere to the right hemisphere, resulting in older adults in a division of labor, with each hemisphere focusing on distinct meaning. Similar age-related increases in bilateral activation patterns have also been noted in the hemodynamic imagining literature for a wide range of cognitive processes. Building a message level representation. The ability to monitor processing as it unfolds during naturalistic tasks such as reading or listening for comprehension has made ERPS an especially useful tool for studying sentence and discourse processing, and it is at this level in particular that important, pervasive age-related differences have been noted. In one study, for example, younger and older adults listened to auditorily presented sentences that were either congruent or grammatical but nonsensical and could contain a sentence medial pair of associated word or not. This is according to Ferdinand and others of 2003. Thus, although younger and older adults responded similar to lexical association, older adults displayed a qualitatively similar but substantially delayed response to sentential context. Gunter and others of 1982 came to similar conclusions using slightly younger population, suggesting that declines in sentence level comprehension begin by at least the fifth or sixth decade of life. Fedemir and Kutas of 2005 further explored the use of message level information by older adults and examining the impact of sentential constraint. Sentences were either strongly constraining with predictable ending or were weakly constraining with an unpredictable ending. For our conclusion, aging brings a lifetime of experiences and knowledge that remain largely intact as the brain grows older. The evidence provided by the electrophysiological investigations of language comprehension during aging shows that the organization and structure of semantic knowledge is similar across age. But when integrating meaning across words to form message level representations, older adults shows both quantitative and qualitative changes in processing. All of these changes are modulated by individual differences, highlighting the importance of understanding what types of abilities, strategies, and brain states may protect against some of the declines in comprehension seen in old age. That's all, and I hope you learn a lot.